Okay, so let's go ahead and work through an example of sulfur dioxide and drawing its Lewis dot structure. So as always, the first thing we want to do is find the total number of valence electrons for our structure. So in this case, we have one sulfur. Sulfur has 6 valence electrons. And then we have 2 oxygen. And each oxygen also has 6 valence electrons. So if we go ahead and calculate that, we end up with 6 plus 12, or 18 total valence electrons to work with. Now, as we think about this structure, we want to put the least electronegative element in the middle, which in this case is going to be sulfur because oxygen is closer to fluorine. So remember, fluorine is the most electronegative element. The closer you get to it, the more electronegative the element is. Okay, so we go ahead, start by connecting everyone with at least one line. So when I do that, I've used up 4 valence electrons, so I go ahead and subtract those 4. That leaves me with 14 valence electrons. Now I'm going to go ahead and take those valence electrons and put them on my outside atoms first. So I'm going to go ahead and put 6 on my left oxygen, and then 6 on my right oxygen, because that brings them both to their octet. So far I have used 12 additional electrons, leaving me with 2 total electrons to work with. So I'm going to go ahead and put them on my central atom, which is sulfur. And then I want to go ahead and evaluate. So if I look at the oxygen on my left, it has 8 valence electrons, which is what it wants. My sulfur atom in the middle, however, only has 6 valence electrons, 2, 4, 5, 6, which is not enough. So in this case, I need to actually go ahead and form a double bond. So I'm going to cross out a pair of lone pair electrons and change them into a bonding pair. So when we go ahead and check this out, this oxygen still has 8 valence electrons. Now my central sulfur atom also has 8 valence electrons, so 2, 4, 5, 6, 7, 8. And then my oxygen on the right also has 8 valence electrons, so 2, 4, 6, 8. So that is a valid Lewis dot structure of sulfur dioxide. However, you might be wondering, why didn't I take the electrons from the left oxygen? Well, that would be an equally valid option. I could have taken them from the left just as well as I took them from the right. So this molecule is actually an example of something called resonance, meaning there are 2 options, both of them are equally valid. So in order to display this to our audience, we actually need to use a double-headed arrow, meaning that we're going to see both of these structures. There's actually some ability of electrons to move back and forth, so both of these are fair. So if I go ahead and draw out the other option, it's going to look basically the same. In this case, I'm just moving where I have that double bond. Okay, so if we look at this, sulfur in the middle, it still has 8 valence electrons, so 2, 4, 5, 6, 7, 8. My oxygen on the right has 8 valence electrons. And then my oxygen on the left also has 8 valence electrons. All that I'm doing with this arrow is showing, hey, my double bond could either be on the left or on the right. Both of them are valid options. So that would be my answer for this problem.